video, we are going to build a small tool that connects to an Android device using ADB. We'll handle errors properly, get the device IP, switch to TCP mode, yeah, and finally connect to it. All using Rust, of course. So the first thing you're going to do is create a binary called ADB Rust. And even before you start the project, we are going to use this crate known as ADB client. So let's add ADB client on our project, and then we finally cargo build the project. Since this is the first time we are building the project, it will take some time. So let's wait as the project is building. As we are waiting for it to build, let's see some example from the documentation here. The first thing we'll need to do is create a server, ADB server, and then attach then get the device from the server. Then finally we shall be running shell commands from the device which it has been attached. Okay, let's start. So we will create a lib.rs file, then create a public function called launch, and as for now we shall print hello world. First we'll create an ADB server instance. This sets up communication with any connected devices. Next, we try to get a connected device. If there is no device attached via USB, we can return a custom error. So we'll create a mode called custom error.rs, and then create a public enum known as my ADB error, and then derive debug. So what this variant ADB brackets ADB error is doing is basically letting us to take an existing error, in this case from the ADB library, and then it wraps it inside our own custom error. Meaning we won't lose any of the original details, but we can still handle everything using our ADB, our my ADB error type. Alright, now we will implement the display trait. This is what will allow us to turn our errors into human readable messages. Basically, when we print our error using something like, let's say, print line, this is the message that will show up. We use match to check which variant of the error we are dealing with. If it's an ADB error, for this case, we will include the original message. Otherwise, we shall just return a clear message like no devices connected or anything else. We shall do that later. Next, we implement the standard error trait. This one is very simple. Rust just needs it so that our type officially counts as an error, which it lets us work with the question mark and other error handling tools like anyhow. So finally, we will implement the from trait so that you can convert any ADB error into my ADB error automatically. This means that if some function returns ADB error, we can just use the question mark and Rust will handle the conversion for us. No need to unwrap it every time. It's super convenient, right? Okay, let's continue. So we need to add no device connected error to our enum so that you can use it as a custom error on the other end. So we will map the error, and if there is an error, it will return no device connected. To make error handling work properly, we need to change our main function and the launch function to return a result with the custom error, my ADB error. This lets us use the question mark operator inside them and return any error that may occur, for example, when there is no device connected. So let's run it and see what we'll get. No device connected. And if I connect my device, we get an output. Nice. Device connected. We are starting with a function called get device IP. It takes a mutable reference to our ADB device and it returns a result. If everything works, we'll get the IP address as a string. Otherwise, it will return a custom error. First, we'll create a buffer called output. It's a vector of bytes where shell command will write it output. So let me break down this command real quick. IP. This is a tool we use to show or configure network interface. Track O, it stands for one line. It allows us to print everything in one line. Tag 4, we use it when you want to show the IPv4. Without this, it will show even IPv6. Address, this tells the command you are looking for address information. Show LAN 0. This says that we want the IP address of the LAN 0 interface, basically which is Wi-Fi. And that is the output of the command. Okay, let's go back. So we'll run the shell command on the device. This one asks for the IPv4 address on the LAN 0 interface. Basically, it's the Wi-Fi interface. We then pass the output buffer by mutable reference so that it can be filled with the result. And we add the question mark at the end so that if the command fails, the error will return immediately. If we run it in debug mode, we can see we are seeing raw bytes as the output. Next, we take the raw bytes from the output and turn them into readable string. We'll use from UTF-8 lossy just in case there's weird character so that it won't panic. Now this is the part where we extract the actual IP address. First we'll go line by line, take the first line, then split it into pieces using white spaces. We look for the fourth item. That's where the IP address and the subnet info is. Then we split it again using the slash symbol and grab the IP part. Let's debug and see what we'll have. Awesome. So if anything fails, like for example, the format is wrong, we'll return a custom error. We shall call it malformed output. Let's create it. So under our custom error, we shall create a new variant inside my ADB error, a new called malformed output, and its custom message will be could not pass IP from the output. Finally, if everything works fine, we'll get the IP address as a string. So let's store the IP address in the variable called IP on the launch function, and let's debug the information. Nice, we have the IP. Then we'll create the enable TCP IP function. It takes the device and port number, usually 555, and tries to switch the device into TCP IP mode. Here we build the command string, something like TCP IP 555. This tells the ADB to restart the device in TCP IP mode on that port, that's 555. Just like the other time, we create a buffer to hold the shell command output. We send the command to the device using shell command. We run it using shtaxi so that it executes as a full shell command. Then we'll ignore the results, because if TCP IP is already running, it might fail, and that's okay. We finally run the OK. So we are not worried about whether the command will succeed or not. We'll just try it. So on the launch function, we shall enable TCP IP. We shall call the function enable TCP IP, and then create a variable called port, which will have our port number. There's nothing on the output because we never displayed anything, so we are not expecting anything to come from the output. Okay, let's continue and find a way to connect to the IP. So we will create a function called connect to IP. It takes the IP address we have just gotten alongside with the port number. It tries to connect to the device over the network using the ADB. Just like before, we will start by creating new ADB server instance using the default. Next, we build a full socket address using the IP and port. We pass the IP string and wrap it through the port into socket IP address 4. So that's what the connect function expects. After that, we connect to the device using connect device. If it fails, we print the output of the address and the actual error for debugging. Then we return our own custom error using the map error. Let's create another variant in the my ADB error, custom my ADB error enum, and it will print could not connect to the IP port, to the IP. Yes. And again, the question mark will return early if there's an error. So if everything works fine, we print the success message showing the IP address and the port we have connected to. So on the launch function, let's call connect to IP and give it correct IP address and port number. Awesome. Cargo run and it connects successfully. Now, if we rerun again, we get an error saying no ADB device connected, but we have connected. So let's see how we can fix that. First, let's comment out where we get the devices. We will use match so you can see real-time error. This helps us to print the exact error message from ADB. From there, we can decide which custom error we can return. We are using match on server.getDevice. If it returns okay, we just take the device and move on. But if there's an error, we go to that branch. We print the ADB error with the ePrint line so that we can see the exact error, what's the exact problem. Then we return my ADB error connection failed, which is a custom error. So let's first comment out this other code so that we can run the rest of the code without errors. Awesome. So as you can see, if we run, we'll get the ADB error, too many devices connected. So let's go and create the custom error that will handle it. Now let's rebuild device. So we shall get the device from the server using get device. If it fails, we shall use map error to match and handle the specific error. So if the device is not found and the message contains too many devices, we shall return too many devices error. So let's go and build it. Under custom error, we are going to create a new variant inside the my ADB enum. So we will call it too many devices, and it will return a custom message saying too many devices connected. Awesome. So let's finish creating the device. It will return too many devices. Then if it's just no device found, we shall return no device connected. For any other error, we shall return connection failed. So let's comment out the match statement we created and uncomment the other code that we had commented earlier. So with the tool we have built, we can now connect to the phone, and if something goes wrong, we'll get a clear error message depending on what exactly failed. Like if there's no devices connected, too many devices connected, or if the connection didn't go through. Alright, now that we can connect to the phone and handle errors properly, we are in a good place to build something cool. So in the next video, we might look at screen capturing, maybe building a forensic tool, or even trying out some simple malware scanner. Something like that. Okay. Anyways, have a good day.